Now, in this lecture, we shall learn that how we can calculate the seismic forces, or we can say do the seismic analysis for the concrete structure with special moment resisting frame. So, in this lecture, we have considered normal car parking, and the structural system that we have considered is concrete structures, and the moment resisting frame, that is gonna the special moment resisting frame, fully ductile. So after that, the number of levels that we have assumed in our structure is 4. That is level 1, 2, 3, and 4. And after that, the earthquake imposed combination factor, as it involves a lot of vehicles. So that is why the earthquake imposed combination factor that has been considered as 0.6. So this is the like a sketch here. So the height has been considered as 3.5 meter for each individual floor level, and 4 number of levels are considered. So after that, if we are talking about the gravity load, so permanent action at level 1 G1, that has been considered as 1000 kN, and imposed action on level 1, that has been assumed as 750 kN. Height at level 1, that has been assumed as 3.5 meter. So seismic weight at level 1, that is basically the full value of the permanent action, that is G1, plus chi c, that is the 0.6 factor, into Q1, that is the imposed action. So 1000 plus 0.6 into 750. So this value comes out to be 1450 kN. Similarly, we have assumed the value of G2 as 2000 and the live load as 750 kN. Now height at level 2, that is basically 7 meters. So 3.5 plus 3.5. So the height from the ground level, that shall be basically 7 meters. So this value, we can see that 2000 plus 0.6 into 750. So this value comes out to be 2450 kilonewton. And after that, if we're talking about the level, we can say level 4. So similarly, we can find out the level 1, 2, 3. So after for level 4, that is 1250 and 500. So 1250 plus 0.6 into 500. So this value gives us 1550 kN as the seismic weight. And structure height at level 4, that is basically 14 meters. Now if we find out a total seismic weight for all the levels, that is, we can say 1450 plus 2450 plus this particular number, that is 2450 again, plus 1550. So this gives us approximately the total seismic weight as 7900 kilonewton. Now the location of the structure, that has been assumed as Port Lincoln. Importance level, that has been considered as 2. So as per the importance level, our annual probability of exceedance is basically, we can say 1 by 500. And probability factor Kp is 1. Hazard factor, as per the location, that is basically 0.1. So Kp into Z comes out to be basically 1 into 0.1. So this value comes out to be 0.1, that is Kp into Z. Now the soil that has been assumed, let us say it is rock and site subsoil class. So as per the rock, the site subsoil class is basically BE. And earthquake design category, as per this Kp into Z, and as per the soil, and as per the height of the structure, that is 14 meter. From the table, we can easily find out as earthquake design category 2. So in here we can see that importance level, that has been considered as importance level 2. So this is basically table 2.1, and the Kp into Z value, that is basically 0.1, and the type of the soil, that is basically BE. So for BE less than 0.11, so we do have to consider this value here, and height of the structure is between 12 to 50. So earthquake design category is 2. So that is how we have calculated the earthquake design category for this particular building structure. So let us assume that if the height of the building is greater than 50 meter, then the earthquake design category is 3. So this is now clear to us that how we can calculate the different parameters for as per the AS1170. Now if we want to find out the horizontal equivalent seismic static forces, we just have to first of all find out the structural form factor. So for, we can say, reinforced concrete moment frame, KT value is 0.075. So in here we can see that as per clause 6.2.3, KT value is 0.075 for moment resisting concrete frame. And after that, we have to find out the value of the, we can say, natural time period of the structure also. So that is 1.25 KT, that is 0.075, and HN to the power 0.75. So HN is basically the height. So HN in our case is basically 14 meters. So calculating this particular, we can say, whole equation and multiplying it with the 0.075 and multiplying it again with 1.25 gives us the value as 0.679 seconds. After that, natural period exponent is basically T1 divided by 2 plus 0.75. So in here we can also calculate the natural period exponent. So 0.679 divided by 2 plus 0.75 gives us approximately 1.09. That has been considered here. And after the spectral shape factor CST, so that has to be taken as per the code. So table 6.4 help us to calculate the value of the CST. So in here we can consider the soil category B, that is rock, and our time period in our case was approximately, we can say, 1.01. Sorry, 0.679 second was the natural period of the structure. So 0.679 comes out approximately here. So in here we can, this value can be interpolated between 1.47 and 1.26 to find out the value of the, we can say, CST. So the value that has been interpolated comes out to be approximately, we can say, 1.3. So on this value, CST is now 1.3, a spectral ductility factor. So for reinforced concrete moment resisting frame, the mu is 0.4, and performance factor for reinforced concrete moment resisting frame is 0.67. So after that, we can find out the effective horizontal equivalent static force. So Kp that already we have calculated, Kp into Z is 0.1, and CH into T that we have already calculated as 1.3, and SP is basically 0.67 divided with mu, that is 4, and this whole equation needs to be multiplied with the total seismic weight, the one that we had calculated here, that is 7900. So we first of all just calculate this particular equation and then multiply the 7900. So this comes out to be 171.6 kilonewton. And so this value 171.6 basically needs to be divided onto the multiple flow levels. So for level 1, we can just simply use this equation, that is W1 into S1 to the power k divided by summation of WHK. So this number comes out to be 0.067. So 0.067 multiplied with 171.6 gives us 11.4 kN. Similarly, 0.239 multiplied with 171.6 gives us 41. And after that, again 0.372 multiplied with 171.6 gives us 63.9, and 0.322 multiplied with 171.6 again gives us 55.3 kilonewton. So that was the basic example on how we can calculate manually the horizontal equivalent static force acting on all the multiple floor levels as per the importance category and as per the, we can say, height or the soil, or how exactly we can calculate the earthquake design categories. So first we do need to learn the theoretical examples. Only then we shall be working with all of these parameters comfortably in the software.